Hi, everybody. Welcome back to the Google Students YouTube Live series. Today we're going to be talking about technical development for first and second year students. So just a reminder, if you're watching this live, please fill out the RSVP form. If you're watching this as a recording, ignore everything I just said and enjoy the show. So also, we love questions, and we have some chat moderators, Taylor and Akela. They're in there ready to answer your questions. We'll save some time at the end to answer questions, but feel free to ask away. Okay, so today we're going to start talking about your career in CS, and we're going to give you some tips and tricks on skills and resources you can use throughout your college career. So you might not be in your first or second year, or you might not have an interest in software engineering. Totally okay to stay. Some of this information could be useful to you, but just understand that we're going to be sort of more geared towards first and second year students. Okay, also introducing myself. Hi guys, my name is Ben. I'm a software engineer at Google. I work at the Sunnyvale office on internal tools for Google's call centers. So my story, I did graduate from Stanford with a math degree. And then I took like one grad level math class and I was like, oh my gosh, this is so hard. So I stuck around instead and got a CS master's. It was a great decision. Fun fact about me, I collect ukuleles and other musical instruments. Okay, here's Christie.
Hi, I'm Christie. I'm also a software engineer. I'm on the Android team in Mountain View. I went to UC Davis and I just graduated last spring. I was an intern the previous summer at Google, which was really exciting in Canada, actually. And I absolutely love movies. That's my fun fact. Even really boring ones people hate, all the movies. Superhero ones I love too. All right. So what does computer science mean to you? Well, it means a lot of things to different people. But some of the three things that we think about at Google are impact, community, and being an inventor. So impact means making the world better, having a really drive to see the world become a better place because of your software engineering work. You can have an impact on lots of people's lives by being a software engineer, so that drives a lot of people. There's also a community around CS. People think coding is really solitary and you're kind of alone all the time, but your team actually works really closely with one another and you become very close to your team. So it's not as solitary as some people think, and that sense of belonging to that community, both the community at large and your smaller team working in development. The one that for me is really the big one that drove me to join CS was being an inventor, kind of seeing something grow from nothing to just a theory or a design to something fully formed that you can play with, that you can point to and say, I made that, that's because of me. And working really hard on a problem, hitting all those build failures and those bugs, and then finally seeing it to come together as a working product is really rewarding. And that's really one of the main reasons why I really like CS. So some things to consider your freshman year. Obviously, you're going to be focusing on a lot of coursework. One of them that we recommend is definitely focusing on a language like C, C++, Java, or Python. This usually will be an introductory CS class, maybe a sequence of them. But definitely become really strong in at least one language. Core math courses. You may have taken calculus in high school, but continue on with that. You can also do linear algebra or differential equations. Some of those are popular. Linear algebra is actually really interesting for machine learning. So if that's something you're interested in, definitely focus on linear algebra. Definitely do a CS project outside of the classroom. We tend to focus a lot in college on the classes and getting that great GPA, but doing coursework is not the only answer. You need to do work outside of the classroom to build up and practice those CS skills. So doing one CS project, like an open source project or just a project for yourself, is definitely really key. We also want you to have a theoretical understanding of CS, so think computer architecture or Boolean logic or discrete math. So taking a class in one of those fields is definitely something you can consider your freshman year. Building up an understanding of Git and version control and even using the service GitHub to kind of build up your profile of different projects that you've created is also something you can start your freshman year, so you can build on that your sophomore, junior, and senior years to have a really fleshed out portfolio. So getting experience with GitHub and version control early on is really key. And then, of course, beginning to read others' code. You don't work in a vacuum, especially at a place like Google or really anywhere. And so you have to work with other people's code and kind of understand it and be able to add on to it. A lot of projects in college, you're working alone or with a very small group, and you don't have to consider the implications on others or their implications on you. So really understanding how high-quality code is created is something that you want to start your freshman year as early as possible. So developing those skills outside of the classroom, some key areas to focus on are computational thinking and problem solving. So kind of developing those algorithms and that logical ordering to your thought process is really key. Make sure that you create solutions using the algorithmic process, so maybe taking an algorithms class or just starting to think in a more logical way like a computer does is really helpful. And code efficiency. This is really you're only able to grasp this through practice. Seeing what is less efficient, both like say big O notation, which is a determinator of complexity of your code, which you may learn later on in your CS degree. And also just how readable it is. Can someone understand it coming in the future? So those kind of more not classroom-based skills are also really good to develop early on. So maybe you're saying, I didn't do any of that. I am a sophomore and I didn't do any of that my freshman year. I'm not ready. You know what? It's totally okay. There's plenty of time left in your college career, and these are just guidelines and suggestions. They aren't hard and fast rules. So maybe you saw something that you think you might want to improve on. Go ahead and do it now. There's plenty of time left. And if you're still a freshman, definitely focus on that as early as you can to build up that knowledge and that skill set. So on to sophomore year. Ben will take you through that.
So yeah, just some things that we're hoping that you've got to by the end of your sophomore year. And a lot of it is kind of what Christie's already talked about from freshman year, but just sort of having it down really well. So by the end of your sophomore year, we're really hoping that you have a good understanding of data structures and algorithms. So you should be able to do some kind of algorithmic analysis, like big O notation at this point, because it's important to understand not just like which algorithm is the best algorithm for some particular situation, but why that algorithm is better than another algorithm, and like under what circumstances. So most of my job when it comes down to like building stuff and design is really just like brainstorming a whole bunch of solutions, then picking out the best one. I never ever work on a problem where it's like, oh, I need to use Dijkstra's algorithm, and then I just plug in Dijkstra's algorithm. I rarely just look up standard solutions. Okay, so another thing, it'd be great if you're really proficient in at least one programming language. And again, that's like C, C++, Python, Java. So a lot of people, and I'm totally guilty of this too, you learn a new programming language, you write a few lines, and then you like put on your resume proficient in. When we say proficiency, what we mean is you should be able to investigate and then solve problems with that language. So you should have at least one language where someone can say like one of those cool data structures or algorithms, right, from like the last bullet point, like code it up, and you can be like, oh yeah, no problem, I got that, and you can just type it up. Also proficiency it really is about being able to share your code with other people. So it doesn't help anyone if you're the only person who can read your special type of Python. That just doesn't help. And also, if you're looking at your friend's Java and you can't spot the null pointer exception in their code, it's just not that you aren't proficient in Java. So one other thing, really important, do try and have at least one project outside the classroom, like an open source project or something, where you're testing your code, you can debug your code, you're looking at a really big code base. This, I think, is such a good way to get a feel for what it's like to really be a software engineer. So in my life, I work as an independent contributor pretty often on small independent projects. But then also I work with my teammates, my pair program. We look at the same code at the same time, and we talk about what we want to do, and it's slow and it's hard, but we build a feature together. It's not solitary in any way. Also, look into, if you're looking for open source opportunities, you can look into something like OpenHatch or Google Summer of Code. And they're really great opportunities to work on a bigger project, to have a small or big role on a bigger project. So there are a lot of ways to get this kind of technical experience outside of a classroom. So there are all these computer science clubs and societies and programming competitions. And if those aren't available to you, you can start those. You can start those at your school. So the ACM has its own guide on how to start a chapter at your school. This is something that you can do. You can look into app development and work on open source projects. Again, like your GitHub profile sort of becomes your portfolio over time. There's a lot of great online competitions out there that you can join. One that's not on this list that I would recommend is Kaggle, which is really interesting for data science. Personally, for me, I got a lot of great technical experience just from teaching and TAing during undergrad. Even as a math major, I was always really interested in teaching, and I found there were a lot of great opportunities in teaching computer science. And that really it forced me to learn how to actually write code. I couldn't fake it anymore because you have to teach it to people, and I had to learn how to read other people's code. And I had to have solid fundamentals myself before I could try and pass those on to other people. So Google does offer some great opportunities for you in your first couple of years. So you should look into these are sort of ordered in time, and Google Code Jam is coming up really soon. The qualifying round starts April 7th, and it sort of continues throughout the spring. And the idea with the Code Jam is that you're given like a challenging problem, and you have to code up a solution. I've never done it. I haven't done any of these things, full disclosure. But I have looked through some of the problems, and they're really fun, and they're also great practice for interviews. The Google Summer of Code, and now this is actually coming up sooner, even though it's a summer thing. The application is open from March 20th to April 3rd, so you should look into this soon if you're interested. The idea, I should say, this is a really good opportunity for you if you haven't already lined up like an internship or something for the summer. The idea here is you find an open source project listed on the website. You don't have to find it all on your own. You can just go to summerofcode.withgoogle.com, and you apply to work on that project, and then Google pairs you with a mentor, and then the mentor helps you to work for 3 months on that project. So it's a really great experience. The last thing is Ignite CS, and this is really about giving back to your community through mentorship in computer science. So it works like this. You grab an advisor, and then you grab some friends, and then you find like a local school or community organization, think like the YMCA or like Boys and Girls Club, to plan a mentorship program in computer science. Then you get to come up with a budget, propose it to Google, and then Google foots the bill for you. So one great resource for sort of your whole undergrad program is Google's Guide to Technical Development. Check that out. It has sort of like a rough outline of suggestions for your whole time as an undergrad. Aside from that, these other three resources are more for coding interviews, I would say. So Google recommends the Cracking the Coding Interview, the 6th edition, I guess now. Look at practice questions on the Top Coder website, also Elite Code. I love Project Euler. That was so much fun. I mean, I'm kind of a math guy, so it was extra fun. But the idea is you have all these math problems, and you solve them by coding. Oh, I thought it was so cool. Definitely check that out. Okay, it looks like it's time for Q&A. Okay. So it looks like Cookie Monster and Sarab both asked, I want to start contributing to open source projects and build up my portfolio. I don't know where to start. Any suggestions?
Well, a good place to start is to look on GitHub for smaller projects, maybe that you can find an open bug fix request that you can contribute to right away. You'll obviously want to know the language that that project is programmed in before you start looking into that, but that's a great place to look. You can also start your own. There's no problem with that. If you have a great idea for something that might benefit the wider community, you can go on GitHub and start your own project. That's totally cool too.
Also, OpenHatch and Summer of Code are both like more structured ways to get involved too, where you can get paired up with a mentor.
So it looks like Ian asks, what's a good stepping stone to advance in the field of computer science? So obviously your coursework first. Go to class, learn a lot. Those are the kind of key fundamentals to learning a lot about CS. But then you want to move out into your own areas. Like find what your school is really good at. Maybe your school is really strong in machine learning or graphics or security or something like that. And really you can use your university's strengths to find different areas you're interested in. And then maybe the research areas. I did some research while I was in university, which is really cool. You can do other things outside of the classroom as well, like start your own GitHub open source project. I don't know, that's kind of my thoughts on that. Anything to add, Ben?
Yeah, I mean, I think I would also say that my personal experience was not was pretty different from I think a traditional computer science background because I started in math, but I know a lot of people who have had similar pathways to working in computer science. You know, where they're working in biology, and then they discover an interesting problem in biology that led them to needing to code for it, and then that writing code like got them interested in computer science as a field. So I think whatever passions you can bring along or to computer science are really helpful. Oh, another question. So what's one course or project that you're most proud of from your computer science undergrad experience and why? Okay, so I took a class that was awesome on, let's see, well, okay, I took so many awesome classes, but I'm going to say the one that I'm most proud of was a systems class, an operating systems class, where we started with sort of just like a skeleton of an operating system, and we had to build things like virtual memory and file systems. And it was so hard. It was so hard. It was, in many ways, it was one of the worst experiences of my life, working these 40-hour weeks, just trying to get code to compile and run, and eating stale donuts at 5 in the morning. But it was so satisfying. It was like just the best feeling, like being able to point at something in your computer, inside the computer, and make it run. It was so great. Christie, do you have a?
For me, I mentioned doing research earlier, and that was really cool. I got a peer-reviewed paper published at a conference in Italy, which was really fun.
Did you get to go to Italy?
I didn't because I had a midterm that day, so I couldn't go. But I was one of my colleagues presented in my stead. But it was really awesome. So just really utilize opportunities that are available to you. Be a TA if you can as an undergrad. Do research. Get internships. Really, there's a lot of opportunities out there if you just look for them. We have another question. What are the areas that I need to develop in technical aspects to get a job at Google as a freshman? Well, to get a job at Google or an internship at any level in your university career, you should have a very strong command of at least one language because you'll need to interview in that language. But also, you want to have strong coursework in other areas too, like computer architecture and things that build on that foundation. You can also do, like I said before, outside projects that will give you that practice and experience to get ready for those technical interviews.
Cool. We have a question from Shane Wang. What would be a good programming language to be proficient in, Java or C++? You know, so much of working as a software engineer is not about knowing the right language. It's about knowing how to learn languages if you need to, and how to like use the tools that you have at your disposal. So officially, uh, Google is like a Java, C++, Python, C, and a few other languages house. But it's important to just pick a language and get good at it, and then learn other languages. There's no one language that's the best.
Yeah, I definitely agree. My first internship was in an area that I had never done before, and in just a couple of weeks at the beginning of it, I really needed to pick up those skills. So that's one of the things that you really need to focus on, is being able to grasp those concepts of all programming languages that you can apply to new ideas and programming languages right off the bat, so you can adapt easily. So Samantha asks, would you guys recommend building a tech startup, although it may adversely affect your GPA? Well, definitely do both if you can. Have a high GPA and start a startup. Remember that your GPA is a reflection of how much you've learned, hopefully, and that it is part of your overall candidate profile, but that we do look outside of that to your stuff outside of the classroom. So if you feel like it would really advantage you to learn how to start a startup, if you're really interested in that, go for it. Just make sure you have a good balance between your outside of work, or classroom work, and your GPA and classroom work.
Another question. What's the best advice someone gave you during your CS undergraduate career? Oh my gosh, that's so tough. I can't think of anything specifically that anyone told me, but I think that the best advice that I can give someone else is to really follow what you're passionate about. If you're interested in machine learning, find someone doing machine learning and do research with them. If you're interested in like taking math classes, take math classes, and then see how you can make that work in computer science. Yeah, and a third thing. I don't know. Do you have any thoughts?
I don't know, just take advantage of every opportunity. The reason I got the research position was because I'd been a tutor for that professor's class the quarter before. So if there's an opportunity, go for it, jump on it. Just really make good use of your time there, because you only got 4 years at college. So Lucia Kim asks, would you say it's better to focus more on learning other languages over the summer, or try to get experience in the field, research or internships? Both are definitely great. You definitely want to learn more languages and more skills, but you also want to get practical experience, because you may find that certain areas of CS are more suited to you than others, and definitely just get that practice, because practice makes perfect. So if you can do both, that's great. I don't know. I really am kind of on the side of getting more experience, because through getting experience, you'll get more, say, languages and skills that you'll develop, like build systems and other things that you might not just by focusing on a single language. So I would probably say, personally, to go for the experience, but both are great.
Yeah, second that point. Definitely experience. Oh boy. Jingwei asked, my team and I are working on machine learning related side projects. We're interested in learning TensorFlow and found the Udacity course. What are good resources? I know nothing about TensorFlow, which is unfortunate. I'd love to learn more about TensorFlow. But my understanding is, aside from the Udacity course, I'm pretty sure that Google offers some reasonable tutorials. My guess is that if you were to look at communities like Kaggle, there probably are other people who are using TensorFlow where you can ask them questions and just sort of like be a part of that community. But I don't have any great suggestions for you. Sorry.
I've never used TensorFlow either, but I did take a machine learning course in college. So check if your university offers something like data science or machine learning that may have either a professor that's available to help you, or some other resources that are available at your university. So 5PJ and B, great name, asks, Looking back now, what are your biggest regrets or things you wish you had done from your first couple of years of college? In regards to courses or opportunities, etc. That's a good one. That's a good one. You want to take this, Ben, first?
No regrets.
No
no,
regrets.
I think I kind of wish that um, I wish I had taken more CS classes, um, and I wish that I had jumped into like an internship somewhere along the way. So I did not do any internships. I did like one internship at a friend's company. That was fun and interesting, but I did that like after my senior year. So up until that point, I didn't really, like I said, I was a math major. I really didn't do internships, and I wish that I'd done it because I feel like it would have been like I thought that I thought that I couldn't do it. In retrospect, I absolutely could have done it. So I think that would have been a good thing to do that I probably could have done.
I'd say looking into classes that are kind of related to your major, but maybe just are really interesting to you. I feel like a lot of my education was focused on CS related stuff. Um, and it wasn't really the kind of other things that I might have been interested in. So definitely focus on CS, but also other things that interest you outside of that too.
Okay, so Shane has another question for us. What are some ways to get interviews? I applied to several positions, but never heard back from recruiters. Okay, so that's okay. Everyone knows internships are competitive. Don't be discouraged. Uh, keep building your skills, working on your resume and your portfolio, and apply again. I cannot tell you how many jobs I applied to and got rejected for before I got a job at Google. It just takes perseverance. So one thing you can check out is there's a resume video that's on this same Google Students YouTube channel. And I think there's at least one or two other videos that you can check out that should have some information on our interview process and how else you can prepare. So it looks like we're going to wrap up. But just a few final reminders. Please, please, please check out our other videos on the Google Students channel. And remember to look at the Google Guide for Technical Development. And thanks for tuning in. We'll be back with other videos. I don't know, what's our time frame looking like in the next couple weeks.
Thank you guys for participating in this discussion with us. We really enjoyed it.